Is it now recording? See, Suyog, is it now recording? Okay, thank you. Thank you so much. So now what we are doing, what we have done, this A joint we are using as a base node, and with the help of this node, we are creating the other nodes. So B, C, D nodes are in X direction only. So let us say this as a X direction. Yes. Let us say this as X direction and this as Z direction. So that we are going to prepare. Now suppose we are using a translation repeat for the modeling purpose, right? So A joint is created. So from this, we have to repeat this node for how many times? Can anybody tell me? Say in X direction, how many times we have to repeat this node? Yes. Can anybody tell me? We have to repeat this node, A node, in X direction. For how many times we are going to repeat this node? Yes, perfect. It has to be three. You can unmute yourself and you can tell me. Huh? Yeah. So we have B joint here in X direction. We have C joint also. And also we have free end as D. So that means we have to repeat this A joint for three times, right? So steps will be three. And the distance between these steps will be, for first step, the distance will be 4 meter. For next step, the distance will be 3 meter, and then for last step, the distance will be of 1.2 meter. Okay, so that we will prepare this horizontal beam. Okay, so let me complete this one first so that we can go further. I have to share the screen of your Staad.Pro. Okay, I guess screen is visible to all of you. Now we have created A joint and now we are going to repeat this A joint in X direction, right? Because we are interested to prepare first three nodes B, C, D. Okay. So just I will click direction as X. Number of steps will be 3 steps, and the say distances. Distances is given as, for first step the distance is 4 meter. For next step the distance is 3 meter. Sorry, yes, 3 meter. And for next step the distance is given as 1.2 meter. Okay, for next distance, that is third distance, step is given as a 1.2 meter. Now if you click on this
सर
row,
हे परत सांगा सर.
yes, what happened?
परत सांगा हे स्टेप्स आणि स्पेसिंग.
Okay, fine. So see what we have discussed, the A joint that is prepared now, right? A point is prepared, is modeled right now. So with the help of this A joint, we are going to create the further joint in a X direction, that is B, C, and D. Okay. So that means we have to prepare three nodes. We have to repeat this A joint for three times in X direction. लक्षात येते का बघा? B, C, D हे जे 3 पॉइंट आहेत ते आपल्या A च्या X डायरेक्शनलाच आहेत. आणि A जॉईंट जो आहे, जो काय आपण नोड क्रिएट केलाय, तो मला रिपीट करायचा 3 वेळा. म्हणजे मला 3 जॉईंट्स तयार होतील. लक्षात आहे? That's why I have taken here number of steps as 3. Clear? That's why I have taken here number of steps as 3 meter. Sorry, number of steps as 3 and the spacing between these steps. So here जेवढे तुम्ही steps तयार केलाय 1, 2 and 3. So here you can see this 3 rows which are indicating step wise, step 1, 2 and 3, and spacing between these steps, that means first node आणि second node यामधला distance किती आहे, राईट? म्हणजे प्रिव्हियस नोड आणि नेक्स्ट नोड यामधला डिस्टन्स. तर पहिला AB स्पॅन जो मगाशी दिला होता मी तुम्हाला, तर त्या AB स्पॅन मध्ये तुम्हाला स्पॅन दिलेला व्हॅल्यू 4 मीटर. सो आय हॅव टू टेक स्पेसिंग ॲज 4 मीटर फॉर फर्स्ट स्टेप. इज इट क्लिअर? इज इट ओके प्राची?
ओके ओके सर.
Okay, for next step, that is for span BC, for span BC, the span is given as 3 meter. Okay, span is given as 3 meter. That's why I have taken here the next spacing, that is for step 2, the spacing is taken as a 3 meter over here. Okay, and the last span, that is the overhang span, that is taken, that is given as a 1.2 meter. That's why I have taken here the spacing as 1.2 meter. Is it okay? Is it okay? Is it clear?
Yes, sir.
Okay, fine. So now this is stepping is over. Now if you click on OK over here, then what will happen? This A joint will be repeated for 3 times with this spacing which we have provided. But also we have to connect all these nodes, right? So that the beam will be formed, right? So for connection also, for connection, we have to click on link steps. What it gives, if you create, if you click on link steps, all the steps, all these 3 steps which we have defined now, that will be connected with a simple beam, with a straight line, with a straight beam. Okay, and then I will click on OK, so that you will find, you will come to know the beam is created. Okay, so if you click on shift and n, you will see 4 nodes are created. Let us say first node is A joint, second will be B, third will be C, and fourth will be D, as such. Now we have to create the further column, next column, where we have no PDF. Yes, once again I have to share that PDF with you so that you will come to know now. Okay, yes. So here, see here. Now what happened? Huh. Now we have created this A joint, B joint, C joint, and joint also. Also we have connected all these joints also, right? Now the remaining part is we have to create this E joint, and we have to connect E joint with B point. That is node 2 we have to now repeat, right? This will be your first node, this will be your second, third, and this is fourth. So now node number 2 has to be repeated in which direction? In say Z direction, in say downward direction, right? In Z direction, so that you will come to know, you will have your next node, and the spacing between these 2 nodes is 3 meter, right? Sorry, spacing between these two is given as a 3 meter over here, right? That we have to create now, right? Just I will create this one first in a Staad.Pro. Once again I have to stop this share. We have to share the screen of your Staad.Pro. Okay, so now we have to repeat node number 2, that is node number B, joint B. In which direction? Okay, so it has to be in a y direction, right? So negative y direction we have to create your next node. Okay, so once again I will use your translation repeat over here. The direction is now y direction, but it is in negative y direction. That's why I have to choose here spacing as minus value, minus spacing is 3 meter. Yes, column height is 3 meter, minus 3. Okay, just see the direction once. You have to give the direction. So y direction in a vertical downward direction has to be provided. So it is a downward direction, negative axis. That's why I have taken here spacing as minus 3. And if you click on link steps, it will be created, or say it will be connected both the nodes. So click on OK. So see here, fifth node, that is node number E, is created. Is there any problem here? If it is having, if you are having any problem, please let me know, or otherwise I will go further. याच्यामध्ये काय प्रॉब्लेम आहे का बघा. हे आता फ्रेम तयार झाली, लक्षात आलं. आता या फ्रेमला आपल्याला प्रॉपर्टीज द्यायचे, लोडिंग आपण असाइन करायचे, आणि त्याचबरोबर सपोर्ट सिस्टीम आपल्याला असाइन करायची, राईट. So first of all, I will do a property page. I have to assign a property. So for property, I will select this property page over here. Click on property page so that this window will be appeared over here, and click on define because there is no section is appeared over here. Click on define so that the section will be appeared over here. And what I will do here, just I will use 2 sections. One section is for say beam, and another section is for say column. Okay, so what I will do for beam, I will say I will use section as a rectangular section of say depth as say 0.45 and width as 0.23, okay, in meters, okay, 450 mm by 230 mm, and click on add. This will be my section for column, sorry, beam. And now I will use section for column. Let us say column section is taken as a, sorry, column section is taken as a 0.3, that is 300 by 300 mm. Column I have taken as a say square column. Let it be as it is, okay. And I have created another section as second section over here, and click on close. So what you can see over here, there are two sections as assigned or say defined. First section is related to say beam, and next section is for column. So what I will do, I will select this section which is defined now, and now I am going to assign this one for all the beams, right? So just I have selected this section, use cursor to assign, click on assign, and go to all the beams which are we are going to assign this section property R1 for the beams. So R1 suggests first section is assigned to these three beams, okay? And now we are going to assign second section which we have created as R2, and that has to be assigned to column. So use cursor to assign, click on assigning, and click on column. So section 2, which is defined right now, that is assigned to column only. Okay, after this you can click on close. So now properties have been assigned right now, and now we are going to see the support specification. For support specification, you can see, you can click on support page, click on this support page, where you can see there is no support is added defined. So now our problem statement itself, what it says, your A joint and your E joint will be your fixed joint, right? So I will create fixed joint over here. So just click on create. You will see this type of window. Fixed tab has to be opened. Click on this. Fixity means there is no rotation is allowed, or also no say deformation, or say no settlement. Settlement is also not allowed, right? So all these values, all six values has to be taken as a restraint values, and click on add. So here support 2 is created. Now first of all we will assign this support, then we will go further. So support 2 is selected, use cursor to assign and click on assign. Where we have to assign this supports, for first joint, that is A joint, and last joint, that is E joint. Okay, so as far as this problem is concerned, A joint and E joint are fixed supports. Okay, next we have third point, that is A, B, C, C joint. For C joint, it is given as a pin support. So create, just we have to create pin support right now. So just click on create, and for pin, you can have your tab here, pin support. So pin support, there is restraint values will be your say deflection, displacement, or say settlement has to be restrained, but the rotation of your beam in all the direction in about all the axis is released, is it is not restrained at all. It can be, right? So rotation is allowed. So here fx, fy, and fz is restrained, whereas the rotation is allowed. So click on add over here. So now beam sorry, support 3 is created. Now we have to assign this third number support to your third number node. Just click on use cursor to assign, click on assign, go to third node and click on it, so that support 3 will be assigned to your third node. Is it clear? Is it okay, all of you? So this will be your frame structure is completed. And yes, yeah, okay. So yes, fine. So this is your frame structure. Support system is also given. Now the remaining part is only loading system. So loading system, once again, don't bother about the definition. Just go to load cases. For loading, we have load page over here as a say shortcut method. So here, just you have to add your load case details. So for load case details, just click on it and click on add here, so that you will have your primary value as a load cases. So just use a drop down list of loading type. I will choose first load as a dead load system, and for my understanding, I will give this name as a dead load. So this is for my understanding. Okay, and I will choose next, say load case as live load, and I will write here, I will use as a heading for this as a live load for my understanding, because this title will be visible for me. Okay, just click on add, so that you will have your two load cases details here as a dead load and live load. For dead load, we know that dead load will be comprises of only self-weight of your say structure. So I will just use here dead load, click on dead load, and you can add this, you can add this here, click on add here, so that you will come to know this type of window here. So in this particular window, what you can see over here, the self-weight load value, just a minute, the self-weight load value, just a minute. Huh. So for self-weight load value, please check the direction. The self-weight has to be in a y direction or say in negative y direction. So click on y direction with factor -1, that is in negative direction, and click on add. So that self-weight is added over here. See here, self-weight is added, and click on close. So now self-weight is not assigned yet. Self-weight is only added. Self-weight is defined right now. That means the question mark you can see over here, that means self-weight is defined. Now we are going to assign this self-weight for whole structure, right? बरोबर आहे. self-weight हा प्रत्येक पूर्ण स्ट्रक्चरचा असणार आहे. बीम असू दे किंवा कॉलम असू दे, त्याचा काहीतरी self-weight असणार आहे, बरोबर. So that self-weight has to be added to whole the structure. So click on self-weight and use assign to view and click on assign. सो व्ह्यू मध्ये जेवढे पार्ट आहे किंवा जो काही स्ट्रक्चर आपल्याला दिसतोय त्या पूर्ण स्ट्रक्चरला सेल्फवेट असाइन केला जाईल. It will ask once again whether you want to proceed. Click on yes. So self-weight is added. Right now, self-weight is added. Now we will go for live load. As such, for live load, we have to choose live load and click on add. So while adding this live load, please once again I want to share you that PDF once again, so that you will come to know how the live load or say which type of load cases we have to see. See here. Please. Yes. What happened? Yeah. Here. So for live load purpose, we have been given that UDL is given, UDL is applied on entire beam or say entire this continuous beam from A to D, right? And having magnitude as 18 kilonewton per meter. So this particular UDL has to be provided on entire beam itself, but we cannot provide this UDL for entire beam with one click only, because if you are having this particular beam, but it is a continuous beam having three supports in that, right? We are having three supports here. Support A, which is a fixed, B fixed, C as hinge support. So that means we have three supports. That means the beam is divided into three parts now, right? So that means this continuous beam is divided into three parts. So for assigning this UDL, we have to assign this UDL in three parts, such as first we have to add UDL for AB span, then we have to add this UDL for BC span, and then for CD span, that is overhang span, right? Now we are going to see how we will add this one. So I am going to share now the Staad.Pro file with you. Okay, so now screen is visible, and I guess we are in a live load only. Okay, so live load, click on add, and now we have to add as a member load, because it's a UDL acting on entire span of your say beam. So I will choose UDL, sorry, member load, and here you have to choose uniform force. So that way you can see over here W1 is your UDL. How you will come to know whether the my system is right or wrong? Just check the unit system, kilonewton per meter. That means a UDL only. Okay, so I have to use here UDL value as -18, right? The magnitude is given as 18, and what is the say distances? D1 is the distance. You know about all these things now. So D1 will be the starting point of UDL and your starting point of your say beam. Now the UDL will be in an entire span, so D1 has to be 0 at all on each and every time, and D2 has to be, say, span of your beam. So we have 3 beams, so we have to add this load for 3 times, right? For first span, that is for AB span, we have span as a 4 meter, so I will use D2 as 4 meter here for first span, and I will click add here, so that we will see here one live load is added over here. I will use second UDL for second span of, say, span is 3 meter now. Just click on add, so that we will have second load over here, and the third one is of span 1.2 meter, which is for overhang span, and click on add. So that we have just created all this UDL loads, and here you can see this is the question mark, that means this is not assigned yet. So just click on assign, for the assigning, just click on this, and now we are going to use cursor to assign, so that we can assign, and click on assign. So first system, that is for spans 4 meter, that has to be applied to AB span. Just click on AB span, right? Next force, next UDL has to be for span 3 meter span, right? That is for span BC. Just click on BC, and next is for CD part, that is which one is a overhang span. So click on that overhang part, right? So please check whether the values are right or wrong. So click on Shift plus N. Sorry, what happened? Sorry, just a second. What happened? I don't know. Okay, that is not assigned yet. Fine. Is it okay now? Yes. So shift V value, you will have your values of UDL magnitude. You can see over here. This is visible now. So here the modeling is ended. Right? We have prepared this frame. We have been given the properties for each and every, say, beam and column, and we have created, or say we have created that supports also, and we have added this loading system as well, right? Now we are going to see whether the how this particular analysis will work. So as well as design we will see afterwards. First I will check the analysis, whether the analysis are right or wrong. So go for command menu, click on analysis, and click on perform analysis. Okay, he will ask which perform analysis, which type of analysis you are going to see. So click on all and click OK. No bother about it. Click on now analysis menu and run analysis, or you have your shortcut method control plus F5. So click on this. You will ask structure has been modified, saved or not. Okay, so now it is analysis has been started. You can see over here in this particular window. Whether the window is visible? Is not. Fine, no problem. There is one window. After analysis, you can see there is no errors. Okay. Just try this. Okay. See, this window is visible to all of you, right? So here there is no error as such. That means our analysis method will be okay. It is perfect. Now we are going to use now post processing mode. We are going to see the shear force diagram and bending moment diagram for that. So go to post processing mode and click on done. So here you have to share once again the screen of Staad.Pro right now, right? So yes. So after clicking on this, go to post processing mode. You can see this type of window. Click on apply and OK. So don't bother about it. Here now we have entered in post processing mode, where you can see your frame. And one more thing is, so results menu is there, and we have here section displacement over here. This is a toggle key. Once again I have to share it with you. This is a toggle key, and this is an enabled value, enabled key. If you click on this, it will be disabled, right? So if you click on this, once again it is enabled. So this is called as a toggle key. Or also we have here shortcut here. This is a deflection shortcut. So make sure that it is enabled, and see here this will be the displacement, but it is not clearly visible right now. So for visibility, click use control click on control and use your scroll button of your mouse and scroll it down and or up in both the direction. You can see whether the displacement is visible or not. So this will be your say displacement of your say total frame. It cannot be manually find out. It cannot be calculated with the help of manual analysis. So don't bother about the manual calculation of this one. Just use this particular say picture for our analysis as far as Staad.Pro is concerned. And what is the value of this one? How you will check? Just go to result menu, use view value option over here, and I'm interested in a beam result, so I will choose here beam results, whether you can have displacement. So I will use here displacement value maximum resultant, and I will click on annotate so that the value will be visible. Right now the value is not visible because the maximum value is shown here over here as 0. 0 indicates there is some value, but it is say of some minimum value, right? Because the displacement is in meter, it is given in a meter, so the value will be negligible as such, so don't bother about it. So otherwise don't take this particular picture as well. Okay, don't bother about it. Let it. So I will disable this deflection option now here. Now I will see whether the shear force diagram is right or wrong. So once again, I will check here shear y force, because shear force we are interesting, we are added here in y direction. So shear force diagram for y direction is given here like this. So once again, for scaling purpose, we are using control plus scroll down option so that it will be visible to all of you. Okay. And now we are going to see what is the value of this shear force diagram. Okay. So for that, what we will do, yeah, sorry. Go to results, wave value, so that click on beam nodes, right, and click on shear force value. Let me take only Ains value and just I will check what happened. Yes, displacement we have to disable. So here, shear force, you can see the shear force value for A joint is 38.144. For B joint for AB span, that is 33.854856. So this is called as a shear force diagram, SFD. And now we will see whether this one is right or wrong for with the help of our analysis, manual analysis. So I will using, yes, I am going to share this SFD now, PDF value. Yes, just we will check whether the SFD is right or wrong. See the SFD say shear force diagram will be similar to all similar to this, which is given in say Staad.Pro value. So there is only one thing is with the help of say manual calculation, the shear force value at A point is 37.15, whereas Staad.Pro is given as 38.15. Okay, there is one some uh, there is some error will be there, right? No worry, this is acceptable. So as per the manual calculation, this is 37.15, and with the help of Staad.Pro, this is 38 point something. Next one is for B point, this is 28.63, and here in Staad.Pro, it is given as 28.22, right? So there is no say any difference. So negligible. This will be the negligible difference we can say. And for C, the difference, the value is 21.6. For Staad.Pro, it is exactly 21.6, and for the this value, this negative value is 25.37. For Staad.Pro, it is given as 25.78. Okay, and this thing, that is 0.551, that is given in a Staad.Pro as 0.025. Okay, so that means my shear force diagram is perfect as per as my Staad.Pro and my manual calculation is such. Okay, I'll show you here the Staad.Pro window also here. Okay, see here. So this is your shear force diagram. So just use the take picture so that you will have your shear force diagram in your say result, say reports, and click on OK so that you can create the report of the same. Okay. Likewise, you will see the say bending moment as well. So here this will be the bending moment of your say frame. So for that you can go for bending analysis, bending annotate. And if you see here, it is not visible right now. Some values are overlapping to each other. No worries, it will be as it is. No worries for all of us. Okay, so bending moment, for bending moment, in our manual calculation, what we have done, or bending moment calculation, what we have done, we have superimposed your free end moment and your fixed moments, right? Free end moment and your fixed end moments over each other, so that we will come to know this type of bending moment diagram. But don't worry about it, just check whether my this moment values are right or wrong. Okay, if it is okay, then we don't bother at all. Okay, see here the moment value. So for a point, the moment ma is comes out to be 25.53 with the help of analysis, manual analysis. And in the Staad.Pro, it is showing as a 27.26. Okay, 25.53 to 27.26. It's okay, no problem. For joint B, it is showing 18.685 for span BA. In manual calculation, it is given as a 20.93. For BC span, it is 16 point something. And in manual calculation, it is given as a 17.86. And for say BE part, it is given as 3.07, and here it is given as a 2.07. Okay, that means there is some error that will be that we will see how it will work or why it is happening. Okay, I will share you afterwards why it is happening right now. Okay, so this will be your bending moment diagram. Just I will be sharing this window, Staad.Pro window now to you. Yes, so this will be your bending moment diagram. Okay, this will be analysis part. Now we will see how the designing works. Okay, analysis part is clear to all of you. Now we will see how we can design this particular frame. So for designing, just we have to go for once again the modeling purpose, modeling value, modeling mode, such we can say. Okay, so modeling, we have entered modeling mode now. And for designing, just click on command menu. The only simple steps are there for designing. Click on command menu, go to command menu. I guess screen is visible to all of you. And the second last option, second last tool you can see over here, that is design. So we have entered here design, but here there are some design, but we are interested only concrete design, RCC design. So click on concrete design. Okay, so after clicking this, you will be having this particular window here, concrete design whole structure. So here you can see the current code for the starting, say practical only. We have configured your Staad.Pro. That's why here you can see the IS code, which is given as IS 456. Okay, make it as it is, no problem. Okay, and here there are some commands, right? So first there is a select parameter, next one is a define parameter, and the last one is a command. Just we have to enter these three values over here, right? So first I will click on select parameters, which parameters we have to select on the basis of which we are going to design. Sorry, this code is changed a bit. I'm scrolling down. Okay, no problem. So here just click on select parameters. So after clicking on this, you will find this particular window in which you can have this number of parameters are there which are selected. I'm not using all these parameters. So I will just, what I will do, I will unselect all the parameters first, and the selected parameters only I will choose for this as a selected parameter. Okay. So for this, I will choose first as a compressive strength of concrete. See here, FC is a compressive strength. Just click, just double click on it. So it will be now in a selected parameters. Okay. लक्षात येते का? So we have to select some parameters for the design verb, say design basis. So I will choose first FC, that is compressive strength of concrete. Then I will choose FY main, that is yield strength of your main reinforcement bar. Then FY secondary, that is yield strength of your shear reinforcement. Then maximum main size, that is maximum size of your main reinforcement steel. Then maximum size of your secondary reinforcement. Then MD1, that is main bar minimum size for bar combination. I will explain what the combination is. Okay. Next is MD2, that is main bar maximum size for bar combination 2. Okay, that we have to select, right? After that, we can select the minimum main size, minimum secondary size. Then we have to select track parameter. That's it. Okay, how many parameters we have selected? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so all these parameters has to be selected first. Okay, clear? So video recording is okay, no problem. So all these 10 values has to be selected first and click on OK. Okay, so first step is over in design step. First select parameter. Now we have to define all these 10 parameters. Okay, so click on define parameter. So we have selected these 10 parameters only. You can see over here these 10 parameters we have selected. Now we have to define these parameters. First one is the FC, that is compressor strength of concrete. So if suppose we are going to construct M20 design concrete, then we have to use here 20,000 kilonewton per meter cube per meter square as a compressor strength. If suppose M25, then we have to use 25,000 kilonewton per meter square. Okay, so this will be your compressor strength of your concrete, and that has to be defined first of all. Okay, and and writing all these things, you can add these things so that you will come to know. Okay, after all these things, I will show you. Okay, so that is added over here. That is FC. Now we have to add FY main. FY main is nothing but yield strength of your main reinforcement, which will be used for the reinforcement detail, reinforcement as a steel. Okay, main reinforcement monthly. So if it is having a 415 mm, say steel bar, we are going to use. So in that case, we have to use 1415000 as yield strength of your main reinforcement steel, kilonewton per meter square, and click on add. Okay, F was secondary for shear reinforcement. We are generally using 250 mm grade steel. Okay, so I will use here 250,000 kilonewton per meter square as yield strength of your shear reinforcement and click on add. Then maximum main bar. So maximum size of your main reinforcement, which you are going to use while the construction. So I will choose here as say 25 mm. Okay, किती number of sides चा तुम्ही maximum size किती पाहिजे main reinforcement. Suppose 25 mm चा फक्त मी बार use करतो maximum. ठीक आहे. So I will choose here 25 mm and click on add. Maximum secondary reinforcement, I will use 12 mm secondary reinforcement of having 250 grade steel, right? So I will use here 12 mm and click on add. MD1 value, that is the main bar minimum size for combination, right? So combination साठी तुम्हाला माहिती आहे की बाबा ज्यावेळी तुम्ही AST कॅल्क्युलेट करता, आय गेस तुम्हाला माहिती आहे तुम्ही एखादा बीम कसा डिझाईन करताय, स्टील काहीतरी कॅल्क्युलेट करताय, AST कॅल्क्युलेट करताय आणि त्या AST वरून तुम्ही फाइंड आउट करताय की बाबा किती स्टील लागणार किंवा किती MM चा बार तुम्हाला लागणार. ठीक आहे, एकदा जर तुम्हाला AST रिक्वायर्ड जर माहिती असेल तर त्यानुसार तुम्हाला कॉम्बिनेशन डिफाइन करता येईल बाबा किती कॉम्बिनेशन किंवा किती नंबर ऑफ साईजचे डायमीटरचे बार्स तुम्ही यूज करू शकता. So for that you are going to use this combination, and for that main bar minimum size is 10 mm. याच्यापेक्षा खाली आपल्याला जायचं नाहीये मेन बारच्या कॉन्फिगरेशन साठी. So it is to be used as a 10 mm and MD2 let it as be say 12 mm. Maximum size for bar combination main bars 10, so at 12, and then minimum size of your main reinforcement let it be as 10 mm. Okay, main reinforcement ला जो minimum bar जो आपण यूज करणार, let us say 12, 10 ठेवूया का 12 ठेवूया, let us say 12. Okay, okay fine, 12 mm let it be. Minimum secondary reinforcement आपल्याला minimum काय घेऊया, 8 mm घेऊया, 6 mm ला जायला नको, let it be as 8 mm. Okay, so click on add this, and the last parameter is track parameter. If you use this parameter, then and then only the design will work. Okay, so just use this track parameter so that the minimum details can be printed out. So click on add. right? So make sure that all these 10 things have been added over here. See here, FC, FY main, FY secondary, F maximum main, maximum secondary 5, MD1, MD2 7, and minimum secondary track are 9. One more thing, minimum secondary, yes. So minimum main is not added yet. Yes, now I have added. See here, this 5, this 2, 7, and this 3, 10, right? So now 10 parameters I have added here. And now we are using all these 10 parameters for total frame structure, right? So just click on all the parameters one by one and click or assign to total view, right? Assign to total view and click on assign. So this FC will be assigned to all the structure. Okay, so each parameter we can assign to total view. Okay, fine. So all the 10 parameters which we have selected first, then defined, and now all the parameters are assigned to total structure. And the last thing is now command. Now for the command, we are using IS456. We have to design beam first. So use design beam and add. Also, we have to design some columns. So click on design columns and add. And the last one is a takeoff so that you can get the final total weight of the steel and volume of concrete which we are going to require for the construction. So for that, please use this takeoff. Don't go for design of slab or element because now we are not interested in a slab element. We are not added here slab element. So just click on takeoff and add over here and click on close. See here, you can see over here, there are 3 points we have just added as a command value. So in which concrete takeoff is added directly and it is also assigned to all the structure. But we have to now assign for design beam. So which beam we are going to design as per as IS 456. So this horizontal beam we have to select. Okay, so use cursor to assign, click on assign, and this beams has to be selected so that IS 456 will be using the beam recommendation which is given in IS code for this selected beams only. And for design column, we will be using yes, use cursor to assign. We will be assigning this particular recommendation for the column which we have created over here. Okay, so now this is clear. Is it okay? Is it clear? So here the design value or design thing is over. Now we will see how it designs or how Staad.Pro will give you the design values. Just I will be using only 10 minutes more. Okay, please bear with me. Okay, so how you will check the design purpose, design value? Just go for once again perform analysis. Don't bother on this. Click on all and click on OK and go on run analysis. Once again, we have to use the same say tool for the design purpose also. So after this, you will be having just I will share that window with you. Just a thing. Yes. So just once again, the analysis is done, analysis and design is done now, and we have 0 error, 0 warning, and 0 note. So after designing the steps value, then we have to see the output file, right? एकदा जर डिझाईन झालं तर आपण आउटपुट फाईलला जाणार आहे. आपण अनालिसिस झाल्यानंतर पोस्ट प्रोसेसिंग मोड मध्ये जात होतो जिथं आपण एसएफडी आणि बीएमडी मिळत होती. पण एकदा जर आउटपुट फाईल जर आपण गेलो तर आपल्याला डिझाईन मिळणार आहे. सो गो टू आउटपुट फाईल अँड क्लिक ऑन डन. So that you will now I will share once again the Staad.Pro. Just a second. Yes. Whether output file is visible to all of you, just please check. If it is not, please let me know. Unless it is not visible.
Not visible.
Okay, wait. That means I have to share that output file structure. Yes. Now, is it visible? See.
Yes.
Thank you. Okay, so this will be your output file where you can see the design of all the design such. So here the results value will be there, and just click on concrete design, right? Because we are interested only RCC design. Click on concrete design. So whatever we have chosen here, all the 10 parameters, this will be listed over here. And so design beam is also listed over here. And yes, no problem. So you can see over here the beam number. This is the now design results. Beam number one is having. So here beam number one, that means your AB span M25 grade system. FE415 steel is used as a main reinforcement. FE250 as a secondary. That we have given the input file. Length is also given. Size we have say used, and cover 25 mm. That is recommended by IS 456. That is taken for the design here. You can see the cover is recommended by IS 456 only. Okay, after that you will see here summary of reinforcement area, right? So in summary you can see the total reinforcement required for each and every section. That means the 4 meter length beam is there, and that is divided into say 5 parts. And here you can see the top reinforcement and bottom reinforcement, or say required reinforcement what we have to provide here, that is given over here. लक्षात येते का बघा? एएसटी रिक्वायरमेंट जे तुम्ही काढताय एएसटी रिक्वायर्ड ती इथं व्हॅल्यू दिलेली आहे. टॉप रेन्फोर्समेंट मला लेफ्ट हँडला तुम्हाला 212 राऊंड फिगर करतोय 212 स्क्वेअर मीटर एम एम ची मला लागणार आहे. आणि बॉटम रेन्फोर्समेंट जे आपण मेन स्टील म्हणतो ते आपण 198 मीटर स्क्वेअर मीटरची एम एम ची लागणार आहे मला. ठीक आहे. आता हे एएसटी रिक्वायर्ड झालं तर त्याला प्रोव्हाइड काय करणार आहे, तर त्यासाठी प्रोव्हाइडेड रेन्फोर्समेंट एरिया इथं दिलेला आहे. टॉप रेन्फोर्समेंटला 12 mm चे 2 बार तुम्ही यूज केला एका लेअर मध्ये तर ते तुमची सफिशियंट एरिया म्हणजे एरिया रिक्वायरमेंट जी काय आहे ती फुलफिल होणार आहे. तसंच बॉटमला जर बघितलं 197 ला सुद्धा तुम्ही 12चे 2 बार जर तुम्ही टाकला तर तुम्हाला हे सफिशियंट आहे. त्याचबरोबर शेअर रेन्फोर्समेंट जर बघितलं तुम्ही, शेअर रेन्फोर्समेंट सुद्धा दिसतंय तुम्हाला 00 म्हणजे किंवा 4 मीटर 4000 mm म्हणजे त्याचे दोन्ही सपोर्ट. तर दोन्ही सपोर्टला सुद्धा मला स्टेरअप जे आहेत ते सेम स्पेसिंग मध्येच ठेवायचे. 2 लेग 8 mm बार at spacing 230 mm. Right. Likewise, we can provide shear reinforcement for each and every beam. Right. So output for bar combination also you can see over here. AST required is 212, and we have been provided AST requirement. AST provided is 226 mm, and also it is given as say development length we have to provide as a 483 mm. 483 mm. So this will be your design purpose. So this is a design beam. Here also you can see the beam number 2 and beam number 3. Likewise you can see the designing value, right? And here it is given as a column also. We have been provided one column, and for column the required steel area is 44.54. If you see the manual calculation, you can see, you can calculate this one. The minimum reinforcement, or sorry, minimum requirement of steel area is 45 square mm only, and required concrete area is this one. And we have been provided main reinforcement as 4 bars of 12 mm diameter, right? And it has to be equally distributed. And tie reinforcement we have been provided 8 mm diameter rectangular ties at spacing 190 mm center to center. So this will be your column detailing, column schedule. Okay, is it clear? So in this you can see, and also track parameter we have been given that track parameters as well. So here if you see the total volume of concrete is used for this particular say frame is 1.1 cubic meter, and for steel we are using 8 mm bar for stirrups as such, and for that we have been required weight in 210. I guess this weight is in Newton only. Okay, yes, Newton only. And of 12 meter diameter, we are using 390 Newton steel is to be required. So total requirements of steel is 600 or say 601 Newton. It has to be required. Okay, so that means the result or say design is over. And if you see that design part of your say, just I will use another 2 minutes only. Just please bear with me. I will share you that screen also here. Yes. So beam schedule, I'm talking about beam schedule. So you have to enter here beam number, right, which is provided for your problem, size of that particular beam, main steel, that is top steel. If it is a through beam or say if it is a provided for entire span of your beam, then it will be called as a through beam. And if you are using this particular beam for a particular say at support only, then that particular value has to be entered in a curtailment as a top reinforcement, sorry, for main steel reinforcement. And say for top steel, the through reinforcement, if it is provided for total entire span of your beam, that is a through beam. And if it is used for say any say end, it is used left end support, then it has to be entered over here. If it is used in a right hand support, it has to be entered over here. राईट. म्हणजे काय या पर्टिक्युलर जो काय मगाशी जी आपण बघितली जी काय व्हॅल्यूज जे बघितले त्यामध्ये प्रत्येक सेक्शनला 2 बार 12चे दाखवत होता. जर सपोज जर एंड सेक्शनला जिथं आपण जो 0 आणि 4 मीटरचा जो काही सपोर्टला आपण जे बघत होतो तिथं जर सपोज काही वेळेला जर 3 बार 12चे जर दाखवला म्हणजे तो एक्स्ट्रा एक बार तुम्हाला त्या पर्टिक्युलर एंडला किंवा त्या सपोर्टला मला ऍड करावा लागेल. दॅट हॅज टू बी एंटर्ड ओव्हर हिअर. Whether it is a left support, it has to be entered over here. If it is a right support, you have to enter here in a right support. And the stirrups you can show here 2 leg 8 mm bar at 230 mm center to center, right? So likewise we have to prepare a schedule of your beam or column. Column साठी सुद्धा same column number, size of column, main steel जे तुम्ही आता प्रोव्हाइड केलाय 4 बार ऑफ 12 mm चे जे काय असतील ते आणि तुमचे stirrups, right? So that has to be provided by you. Is it clear? So I will end this particular say lab over here only. If you have any doubt, please ask me. And if you have any doubt, please ask. Otherwise, I will end this say lecture practical over here only. Just give me a minute so that I will take your attendance. So okay, I have taken your attendance. We will stop here only so that stop